Hi folks, we're going to take a look at number 4 on page 399. So they're asking us to show here that if I have two vectors p and q, that the projection of vector p onto vector q is not necessarily equal to the projection of vector q onto vector p. And they ask us to do this using a diagram, although we'll also see algebraically that this is not true in general. It's a nice question because a lot of our communication question on tests sometimes look like this here. All right, so let me just take two random vectors, p and q. So say this is vector p, okay, and this is vector q. So let's take a look here, and we'll use some different colors if I can find some. All right, so if I want to take the projection of p onto q, so I start at my tip and I just go down 90 degrees to vector q, and then this vector here represents the projection. So this here is the projection of p onto q, okay? And we'll look at it algebraically in a second, but we'll start by looking at it, comparing it to the other one, which is, it looks like I ran out of red pens here, so we'll try using black here. Okay, so if I want to do the projection of q onto p, well, so I'm going that way. So let me just extend p here, okay, and bring this down. So I have 90 degrees. Remember, it's like having a flashlight perpendicular to p above q. So I'm looking at the shadow. So this vector here is going to represent the projection of q onto p. Okay, and right away we can see that these two vectors are not the same. Okay, so by diagram, we can see that the projection of p onto q is not equal to the projection of q onto p. And remember, when we're trying to find a counterexample, that is to show that something is not true, all we have to show is one example. And clearly these two vectors are not the same. All right, now if we take a look at this algebraically, let's look at the formula for projection of p onto q. Well, that's p dot q divided by the magnitude of what we're projecting onto squared times what we're projecting onto its vector. All right, and here the projection of q onto p, well, is q dot p over magnitude of what I'm projecting onto squared times that same vector, and clearly these two expressions are not the same. Sorry, I didn't realize you couldn't see that. Despite the fact that these dot products are equal, I'm dividing by a different value and I'm multiplying to a different vector. In fact, a vector that's not even in the same direction necessarily. Okay, so this diagram here and the actual definitions for these projections show us that projection of p onto q is not the same as, or so here I should say, not the same as projection of q onto p. So in other words, this operation of taking a projection of one vector onto another is not commutative. So the order in which I do it does matter. Okay, that's it for this one.